Good afternoon, everybody. My name's Adrian Worker. I'm from CH2M, and I've been involved in the nuclear industry now for quite some time, and indeed, I started on nuclear new build in the UK back in 2006. So I've learned a few things over the time, and my company's been involved in nuclear projects worldwide and have had, I think, a reasonable contribution to the ANEC project here. So today we're going to talk about, and we've got a panel here of a very good panel to talk about nuclear power, how it fits in the mix, and what are the challenges associated about it. And I'd like to introduce Dr. Toucan, John T. Palmer from PwC, Andrew Oldham from Atkins, and Indraj, did I get it right, from Eversheds. And first, before we get started, I'd just like each of them to give a little bit of introduction about themselves and why they're here, and then we'll get into a presentation from Dr. Toucan about the Jordanian program, which is a good illustration, I think, of some of the challenges of trying to get a nuclear program underway. And then we'll go into talk about why it fits in the mix, why should it fit in the mix, talk about how to bring financing to bear on such a complicated project, and then talk a little bit about the execution. And then I'm hoping after 30 minutes that we'll get into a panel discussion, and I'm hoping that we're going to get some questions from the audience that I can mix with some of the questions I've already got pre-prepared, but I prefer to take them from yourselves. So without holding back any further, would you like to sort of introduce yourself one by one, please?
I'm Dr. Khaled Toucan, the chairman of the Jordan Atomic Energy Commission. I served as the Minister of Energy of Jordan in the year 2011, and I also served as the Minister of Education and Higher Education of Jordan for 8 years, from the year 2000 till 2008.
John T. Palmer, PricewaterhouseCoopers. PwC is very passionate about the energy sector. I lead a team out here which is involved in the nuclear program here, supporting ANEC, but also in the renewables industry and the broader energy sector as well. We have a global team involved in the programs in Veutel in the US, in Hinkley Point and Moorside in the UK, and Daya Bay in China, as well as the program here. Delighted to be with you this afternoon.
My name is Indraj Mangat. I'm a partner with Eversheds LLP, which is a law firm, international law firm. I'm based in London. I head up the project financing group in London. We're heavily involved in the renewable sector, but also as a firm, we're advising one of the Chinese developers on the Hinkley Point C program in the UK.
Good afternoon, everybody. My name is Andy Oldham. I run the Atkins nuclear business here in the Middle East. I've been in the nuclear industry 25 years nearly now, so I'm delighted to be here to sort of talk about how that fits into the energy mix.
Okay, thank you. So I suggest then I invite you, Dr. Toucan, to make your presentation.
Thank you, Adrian. Good afternoon, ladies and gentlemen. I would just like to start, for the sake of time, just by highlighting why Jordan is pursuing nuclear energy. Jordan is a small country with a total area of 89,000 square kilometers. The population is 9.5 million. 1/3 of the population today of Jordan are non-Jordanians, 1/3 actually. You know, Jordan has suffered a lot from the turbulence that is currently taking place in the Middle East. Out of the 9.5 million, we have 1.2 million Syrians, and then a total of around 2 million Iraqis, Palestinians, Libyans, Yemenis, and other nationalities. Now, this has put a lot of strain on the government to provide energy and water, not just to its own population, but to a total of 1/3 extra to its population. Added to this fact is that my country imports more than 97% of its energy from outside. You know, we are in the heart of the Arab world. Up till the 70s, Jordan used to import its oil for free from Saudi Arabia. And part of the deal was that in terms of passage fees, Saudi Arabia would give Jordan's needs of oil for free. Then in the 80s, the Saudi government decided to go on more or less commercial deal with Jordan, so we switched to Iraq. So up till 2003, Jordan used to get its oil from Iraq at very, very preferable rates. We almost used to get oil for $4.5 a barrel. But then with the US occupation of Iraq and the havoc that wrecked Iraq, we switched to Egyptian natural gas. Things went fine, and our electricity system were almost 90% dependent on Egyptian gas until the revolution in Egypt and then the political turbulence in Egypt. So the Egyptian gas was interrupted. So added to all this political turbulence that wrecked our region, the energy system in Jordan was in havoc, and actually we were hanging loose. I show you here the losses for our national electric power company since 2009 till 2015, when we lost Egyptian natural gas due to bombings and irregular interruptions. In 2009, in 2009, actually, we are almost 89% dependent on Egyptian gas, 7% on heavy fuel oil, and the rest on diesel. And the NEPCO was doing well. Actually, they were making some profits. But then look at 2012. The natural gas went to 17% because of disruptions. Then it was substituted by heavy fuel oil and diesel, which is very expensive. And 2015, Egyptian natural gas even went lower. LNG stepped in, which was a big relief, and reduced the share of heavy fuel oil and diesel. But what were the consequences on the country? 2009 was a good year. It was almost break even. 2010, we accumulated $226 million US dollars, raised to $1.4 billion US dollars in 2011. So up till 2015, the total accumulated debt because of electricity generation was $6.8 billion US dollars over 6 years, because we had to substitute natural gas by heavy fuel oil and diesel. And as you know, this is the worst scenario you live in. So the country actually started seeking a more robust energy strategy by diversifying its energy sources, and nuclear is one of them. But definitely there are challenges. We are part of a turbulent region. We have actually to secure proper financing. We are not a rich country. And we also have to address issues related to fuel cycle and waste management. Currently, the commission I am heading, which administers Jordan's nuclear program, we have 3 major projects running in parallel. The first and the most important is human resource development, because nuclear technology is not just about generating electricity, but also about building capacity in the country, manufacturing capacity, sophisticated level of science and technology handling as part of education, technicians and engineers. We are into uranium exploration, leading to the construction of a nuclear power plant to be part of the major energy mix in the country. Our government has taken a decision to adopt nuclear energy as one of the main constituents for its base load electricity. And in addition to that, oil shale is there, LNG, liquefied natural gas, is there. There are still some attempts to explore gas. Solar and wind are being pursued very intensively, as we heard from our minister yesterday, but as you know, solar and wind today cannot be base load. But definitely nuclear, oil shale, direct burning of oil shale, LNG will still be the major pillars for base load generation of electricity in Jordan for the next 2 decades. Jordan is endowed with very rich uranium resources. This is an aerial view which shows the radioactive anomalies. As we see, actually, the middle of the country, where you see the red and blue regions. These are highly populated regions with uranium deposits. Our deposit is superficial. It is low grade, which means that the mining works in terms of cost are very low, but yet you have to invest more in terms of concentration of the low-grade deposit to make it marketable. In the year 2014, we published the first JORC compliant report where we have announced a total of 36,800 tons of deposits, superficial deposits in the country. We continued work since then. We are going to publish the first revision of the JORC report next spring in 2 months' time, where we expect to add additional 5,000 tons to raise our inferred resources to 43,000 tons, and also reclassify resources, at least 1/3 of them, from inferred to indicated. Currently also, we are working on the extraction process. We have built a pilot. We have extracted the yellow cake in our laboratories. The process was developed in-house, and we are now working on the extraction in the field, building a semi-pilot in order to determine the exact cost for extracting uranium through the chemical process. So currently, we have moved from lab work, lab bench scale work, where we have extracted and succeeded in extracting the yellow cake in our laboratories, to a pilot and semi-pilot scale in the field in the central Jordan area. As I've mentioned, it's low grade, and it's a superficial uranium, and we do target that our extraction cost, including, in addition to mining, should be less than $40 to $35 a pound in order to more or less meet the challenges in the fluctuating uranium market prices. I'll move on to human resource development. Most important thing in any nuclear program is to build capacity and develop your human resources. We have established a nuclear engineering department at one of our universities, Jordan University of Science and Technology. The nuclear engineering department has already in place an operational subcritical assembly that has been operational for 3 years to train students on major concepts in nuclear engineering related to reactor control, criticality calculations, subcriticality. In addition to that, we are currently building a 5-megawatt research reactor on the campus of the same university and making it open to students and faculty members in order to train them, also have hands-on experience in training them on the reactor technology as they study. But in addition to that, this is a multi-purpose reactor that will also produce radioisotopes, mainly iodine-131, molybdenum technetium generators for nuclear medicine, in addition to iridium-192 for industrial use. The reactor, the same reactor, will also be used for neutron activation analysis, material studies, and also neutron transmutation doping. It's a multi-purpose reactor. Currently, we are almost 95% complete. We are expecting to receive the fuel from France, from CERCA, which is a subsidiary of Areva, TN, next month. And hot commissioning will start sometime end of March. So the commissioning will take us for 6 months. So by October, we should have the reactor fully operational. The reactor will have 4 major neutron beamlines, one for neutron radiography, cold neutrons, and standard applications in neutron spectrometer, basically a high powder resolution diffractometer, in addition to a time-of-flight spectrometer, and a thermal column in place. These are some of the photos of the reactor building and the facilities inside the main control room. The reactor pool now is complete, and they are now doing the final touches for receiving the fuel from France next month. This is a photo of the hot cells for iridium production. As I've mentioned, we are going to produce iodine-131, iridium-192, in addition to molybdenum technetium. In training, we have sent more than 100 students on scholarships to France, China, Russia, US, UK to do their master's and PhD. having finished their bachelor's degree in our universities. They go now for master's and doctorate studies in the US, UK, France, China, Russia, Korea mainly. And so far, 28 engineers, technicians were trained on Kerry on the operation and maintenance of the Jordan Research Reactor. I'll move now to the nuclear power plant technology selection. We started actually working on the project over the last 4 years. We released an open bid for bidding. We received 4 bids, including a Canadian bid from Atomic Energy of Canada Limited, Areva, who submitted the ATMEA design, Rosatom, who submitted the VVR 1000, and also a Korean proposal by KEPCO. After a thorough evaluation, including the safety criteria, aircraft crash, seismicity, need of water, and following up a detailed, very comprehensive evaluation process that includes, in addition to the safety issues and technology, issues related to capital cost, operating and maintenance, and also at the end, the price, levelized cost of electricity that will be supplied to the grid. The top 2 contenders were the design by Areva, the ATMEA 1, and the AES 92, VVR 1000 by Rosatom. This gives you a summary. The 2 designs were very close, and in terms of safety and affordability, as far as capital cost, we have opted for Rosatom, basically because they agreed to be a major stakeholder contributing at least 50% into the project as a major stakeholder and equity partner, and also because the reactor has been built, licensed, and there is currently an operating reference plant in India in the Kwandukolam. Jordan doesn't have water. Where are we going to get the water from? We are now focusing on an inland site in the desert of Jordan. We have followed a model in Arizona, Palo Verde in US, where there are 3 units, 1,400 megawatts, operated since 1985. We are going to use treated wastewater. Currently, we are focusing on a wastewater treatment plant where water has been treated, then it will undergo tertiary treatment. The top point here in the circle shows the location of the treatment plant. A pipe of water will be extended to the new site. The reactor site is site area 1 here at the end. It's 65 kilometers. We are currently talking to GDF Suez, who are operating the GDF Suez environment, who are currently operating the wastewater treatment plant, and we are negotiating with them a BOO deal to build a water pipe to transport the water from the treatment plant into the reactor site on a BOO basis. Currently, we expect that we will need 25 million cubic meters per annum to cool a 1 gigawatt plant. The wastewater plant produces 105 cubic million meters per annum and is expected to reach a total of 170 million cubic meters per annum by the year 2020. Based on the Rosatom bid, we expect that the price, the tariff, sales price to the grid will be around 10 US cents per kilowatt hour, which will drop after the payback period to around 8 cents. Then it will drop again to 4 cents from 40 to 60 years, after 40 to 60 years. We are currently in the detailed studies, site characterization, environmental impact assessment, cooling water study, grid study, electricity market research, and we expect by the end of 2017 to sign the EPC contract. We have signed a project development agreement with Rosatom on September 22nd to finish the studies, and we also signed an intergovernmental agreement with the Russian government in support of constructing the project. However, the EPC contract has not been signed yet, and it will not be signed until we finish the studies and are firmed on the price of electricity, the needs of cooling water, and all aspects related to safety and environmental protection. What are the investment criteria from our side? And the IRR on the investment should be between 9 to 12%. We are pursuing now a financial model based on 1/3 equity by Jordan, 1/3 by Rosatom, 1/3 by a third stakeholder. We are currently talking to CNNC from China. Currently, we are negotiating a trilateral deal between Rosatom, JAC, Jordan Atomic Energy Commission, and CNNC and other financial institutions in China, where the nuclear island will be built by Rosatom, turbine island and balance of the plant will be built by Chinese companies like Shanghai Electric and other companies who will supply other electrical systems. The price of electricity should be less than 10 cents per kilowatt hour for the first 18 years of operation. We have established a Jordan Nuclear Power Company to be the owner of the project. Other stakeholders like Rosatom, CNNC, and other companies will be major shareholders in this company. A board has been formed to run the company, chaired by an ex-prime minister, and we expect by the year 2024 to have the first unit operational. The second unit should be operational in the year 2025. I'll conclude by just saying that beginning of next month, on February 1st, between February 1st and 4th, we have established an international advisory group from top international leading scientists across the world. Among the members of this group is Mr. Mike Whiteman, the ex-chief of nuclear inspection in the UK, Mr. Richard Meserve, who was heading the US Nuclear Regulatory Commission. We have also the ex-director of CERN, Dr. Rolf Heyer. We have Mr. Akira Omoto, an ex-commissioner. So we wanted to add an international dimension to build public confidence and to ensure our public that we will not take step until we are sure that safety is guaranteed and there is no compromise in safety. And we have some of the top 2 nuclear safety experts in the world, mainly Mr. Mike Whiteman and Mr. Richard Meserve, in addition to other distinguished fellows on this committee. Thank you all.
Thank you. Shall we save questions to later when we get into a question session? So if I moved on to Jointy, you were going to talk a little bit about how the energy mix fits in and perhaps comment on what you've seen in Jordan, how that might apply to other countries in the region.
Yeah, absolutely. So the key question is why nuclear? Nuclear is not going to win a competition for being the cheapest form of electricity, and that's not why anyone goes into the program. We talk in the UK, and I think it's a generally well-accepted concept of the trilemma of energy supply, dealing with security of supply, affordability of supply, and sustainability of supply. Here in this region, we have to add water as a fourth dynamic to that. Dr. Khalid spoke very eloquently at the beginning about the challenges around security of supply that Jordan has had. And the demands and the pressures on gas supply, certainly here in the UAE, has been enormous. And that's been one of the significant factors in the desire for the UAE to develop the ENEC program, which, as you know, is well advanced. So security of supply, fundamentally important. What about the sustainability then? Well, solar in this region is clearly now absolutely competitive with gas. The Aqua Power deal in Dubai has broken the mold completely. So is solar competing with nuclear? And I think the argument has to be no, and they are complementary. The demand increase is such that we need everything we can get, frankly. Solar is never going to be able to bridge through the entire night. Load demand here in these hot Gulf countries is 24 hours a day in the summer. It's 40 degrees at 1 o'clock in the morning. So we need these complementary technologies. It's not an either-or. Solar is not competing with nuclear, however successful it should be. I think the other really important thing to think about is this concept of water as well. And Dr. Khalid, you talked about water, and you have slightly different challenges in terms of water to the Gulf states. But the production of water here at the moment is effectively a byproduct from gas-generated power. That will have to be decoupled as a result. For instance, here in the UAE, the 5.6 gigawatts of power coming online will not produce water. So that has presented some challenges, and the decoupling actually has taken the sector in a very interesting area where it's been demonstrated now that it is more efficient, gas efficient, and therefore cost efficient and carbon efficient, to separately generate electricity with very high efficiency gas or solar or nuclear, and then the new reverse osmosis technology now being proven within the region in Bahrain is certainly going to be the way ahead, I think, for a lot of Gulf states. So I think the answer to be as brief as I can to the question why, and is it competing, is that it's not competing. We need the full mix. And we must then, importantly, another point that Dr. Khaled talked about, the training of their engineers and their youngsters. Here in the UAE, some 3,000 youngsters going through degree training, technician training as part of NX program. So the introduction of new high technology into the economy as part of diversification is as important as the generation of affordable, secure, and low-cost electricity. So I think there is a definite case to be made for it. It's being pursued strongly. I'm very excited about the NX program coming online within the next couple of years here in the UAE. The case has been made, and very interesting to hear Dr. Khaled bringing out many of the same arguments.
Great. Thank you very much, John T.
To what John said, I mean, in the UK, which is slightly ahead in terms of this debate, because we've had a renewables program going on there now for about 15 years, and effectively last year, 16% of our power was produced by renewables, and at the moment, UK government's cutting subsidies in terms of renewables. Hinkley Point C is up, well, is in the process of being discussed, and hopefully it's going to be built, or the PPA is going to be signed soon. There's a huge debate in terms of how many subsidy, or the size of the subsidy which is going towards nuclear. But effectively, I think there is on the one end of the pole a side which actually talks about energy storage and the fact that energy storage, when it's come up and running, would become base load, and is there any need for nuclear at all? I think, I mean, John is absolutely right. There needs to be a complete mix. It's not one or the other. There does need to be a base load technology, and nuclear serves that purpose.
Okay. Indraj, you were going to talk a little bit about the financing side and bringing financing to the projects as well. Do you want to sort of pick up on that a little bit?
Mm. I mean, I think from looking at it from purely the bank's point of view, and I think what Dr. Khaled sort of pointed out in his presentation, is that effectively this is a very long-term project, and the amount of planning which needs to be involved in actually getting these projects off the ground is huge. These are not projects which effectively utilities or any private corporate can do in its own back. It can't be done on balance sheet. It's something where you have to draw in government and government support for. Effectively, yes, you need utilities involved in terms of actually operating and running these projects, but those utilities need to be heavily subsidized by the government, and therefore there needs to be massive political support in terms of subsidies, and therefore banks need to be convinced that political support is long-term. It's not something which is going to be undercut. Banks will be concerned about the construction risk, and to the extent they are going to get involved in construction, as to whether that's going to be supported. Effectively, there's the environmental issues in terms of there's a leak, etc., and what happens with that, and the liability which occur with that, and who's going to pick that up, because that's not something which is insurable. That's something that's going to have to be insured by the government themselves. So there are large concerns in terms of that. In terms of where we are in the UK, there are banks looking at it. I don't think any banks have signed up to it yet because it's still too early. But effectively, this is not something which is totally doable or bankable by the private sector. There needs to be public support in terms of opinion as well, and in terms of the government itself in terms of doing these things.
Can I just pick up on one point on that? This cost of nuclear is a huge argument. There's an interesting read across to solar as well here. We have to effectively amortize the cost of these nuclear programs over the timeline of a PPA that's somewhere between 20 and 30 years. But these are 60-year life projects. And France is a classic example where, by having made the brave choice to build 58 nuclear power stations and paid for that in the first 20-odd years of their lifetime, they then had 30 to 40 years of incredibly low-cost power fueling their economy after they'd paid for their fleet of nuclear power stations. And that is going to be the case here as well. We have to have governments that have got the ambition and the vision to look beyond the commercials of the short-term funding and look at the benefits. And here in this region, those benefits will be kicking in just as we start to get on the cream curve, the down curve of hydrocarbon production. And the interesting thing about solar is nobody has yet operated a solar power plant for 20 years. And the chances are, every indication is, again, that extra life of very low-cost power is going to kick in. And I think this is something that governments have to look at for both solar and nuclear, looking beyond the challenges of the short-term financing.
No, I don't disagree with that.
I'd like to explore in a question piece the IR model that is typically used today in the decision about investability or not investability, and its applicability to long-term projects like nuclear, when money today in real terms is so much less after about 40 years. So I'd like to come back to how we deal with that. But one of the key things, I think, to making sure finances work for you is certainty of delivery. So I'm going to ask Andrew now to talk a bit about project execution and delivery of these things in a reliable manner. And we, CH2, have a bit of a view on that as well.
Okay, thank you, Adrian. So transitioning from construction to successful long-term operation, a supply chain perspective. I think this is the most exciting part of any capital project. It's applicable to any sustainable EPC project, and it's where ENEC are right at this moment in time, so very timely, I think. I'm going to talk to you about 4 key areas. I'll try and do it quite briefly. I know we're stuck for time. Transfer of knowledge to operations staff. The role of a sustainable supply chain, hugely important. We'll touch on the balance of cost versus value and what that really means. And some operational engagement models that may be applicable. Before I do, I just want to give you that don't know an overview of Atkins. I work in Atkins Energy. We're roughly 2,000 people and revenues of about 200 million. That represents about 10% of the Atkins group. We are operating across the world, delivering engineering and design and consulting solutions across a number of sectors in the energy market. Our nuclear business has got a 40-year pedigree, and there's over 1,000 engineers inside Atkins nuclear part of the business, project managers, technical specialists and scientists operating in waste management, decommissioning, nuclear new build and generation. Here in the UAE, we're very proud to be part of ENEC's new build program, as Jonty talked about. That is at such an exciting point in its life during that transition from construction to operations. So many of the points that we talk about today will be very relevant to ENEC. In the UK, we also support the EDF existing nuclear fleet of 8 operating stations and are part of the Technical Services Alliance. So the first of the 4 points I was going to touch on, transfer of design and commissioning knowledge to operators. The key point here really is you can't start early enough. Operators influence the design, the construction, the commissioning, the decommissioning, the waste management of every facility. And all of those have to go through the design phase, and the design phase is the one that starts first. So I can't stress enough that that's the right time to involve them in the design, importantly in the construction, but most importantly, I think, through the commissioning and early operations ramp up. I think that the benefits of doing this are very much associated with schedule. Timescales and speed of delivery are equally as important. And then the intelligent buyer, the development of that design authority and that intelligent buyer capability leads on to the next point about sustainable supply chain. So the role of a sustainable supply chain. A competitive supply chain is one of the most powerful ways to maintain knowledge and drive innovation. Owners need them to be around, they need them to be effective, and they need them to be responsible. They need them to be motivated and challenged to innovate. Develop that supply chain, don't kick it, I think is the message here. I mean, in some cases, we like a little kick, and I think that's quite healthy, but developing that supply chain is incredibly important. Invest in them, encourage them to invest, and take them with you on that journey. In return, I think they will be aligned to the way of thinking. They will act with that longer-term perspective in mind. They will develop their people, their skills, and their capabilities. That competitive tension is always there to make sure the pencil is always sharp with regard to costs. But they feel your pressure. They feel your pressure, and I think they respond to that. So what do I get from a sustainable supply chain? You can throw specific challenges in their direction. They help to manage the peaks in resource, as well as the risks of the troughs. Reducing OPEX costs, working together collectively, flexing for fast response, having the capability, local presence, people badged up, their knowledge and the detailed understanding of the capability. If we move on to commercial aspects, really this is about resources, I think. This is my point here. Balancing cost and value, that long-lived argument about which is cheapest and which is best value. Manpower substitutes are not long-term supply chain partners. They think differently, they act differently, and they price differently. A sustainable supply chain partner will think long-term, will add value, may appear more costly, but will add more value. And I think it's important to balance the cost and the value argument as you're thinking of developing the supply chain. Don't just think about cost, but think about putting a price on the value of having that sustainability. Some common misconceptions about supply chain models. Internal engineering teams are not often able to manage these peaks and troughs. You would have to develop a capability that aligned with the peak demand, and that brings all sorts of inefficiencies and costly elements and redundancy in the system. A huge reliance on the use of original designers of the plant. There are other options to that. That isn't necessarily needed, and it's something we all do in our private lives with our cars, for example, where we take it away from the dealer maintenance at a certain point in time, and I think that concept is very applicable. There are lots of freelance contractors, but there is no limited learning and succession planning in that mode of operation. It may appear cheaper, but in my experience they are not. So how do you overcome this? There are many good examples of service frameworks where we have a healthy competition, and the key word here is flexibility. Flexibility, delivering with speed, procuring with pace, reduce cost. A long-term supply chain will encourage investment in its suppliers. So in summary, I know Adrian wants to get to the questions. I've got 4 key things to leave you with, really. I think early operator engagement, get that future generation involved early and throughout the project life cycle. Develop and energize your supply chain. Involve them in early decisions. Share the vision and develop with them. Don't kick them. Work with them. Excuse me. Feedback and act on that feedback both ways, both into the client and into the supply chain. And don't rely heavily on manpower substitutions. Don't take that short-term outlook. Many costs are saved through that long-term perspective. Thank you.
Thank you, Andy. I think you've had a nice balanced view of a number of key aspects in nuclear power plants, from someone who's trying to get a program going and people who are trying to support them in a variety of different ways. What I'd like to do now is sort of move on to a few questions, but I guess just before I get into the more generally in the panel discussion, there's any questions from the audience to any of our panel specifically relating to the conversations they've had? And just to warn you, it's quite blinding up here. So it's quite difficult to see. I feel like I want to put my sunglasses on. So, so if you can make sure you can show me pretty obviously where you are. So first of all, any questions for any of the panelists? Okay, so I'll move on to the panel discussion now, and I picked out a few things that I really did want to pick up on. I think the first one was about IR model, and I observed that you were talking about your IR model was somewhere between 9 to 12%, and you saw that as a valid IRR. And, but the concept of IRR and the challenge that it goes with nuclear projects is it's such a long-term investment for real hard money and the capital investment required, but the revenue stream comes on quite late, typically well into 10 years when you start to cut soil, but can go on for a long time. And when you get to the end of a 60-year plant operation, the dollar you put in is worth less than a cent probably at the very end, which makes the IRR model very challenging. I just wanted to get a view about, from the panel, and we'll go through each of you in turn, just to say, what things can be done to try and help build a better model to allow proper investment decisions to be made, and how we might tackle that. Sure, let's start with you, Dr. Tugan.
Yes, Adrian, you are totally right. Actually, when you talk about IRR in nuclear, it's really not a precise concept to deal with, because typically nuclear has this characteristic which is different. You have to infuse huge capital investment at the beginning, and once you overcome the hill, then it's smooth sailing. So the IRR probably could be a concept that would apply during the payback period, let's say for the first 18, 20 years. After that, the cost of electricity drops. I know that in France, probably electricity is produced at less than 2 euro cents per kilowatt hour in the US, where probably the value of nuclear would be much appreciated. And if you would project the IRR concept over 60 years, probably the value of it would be much more appreciated. So I do believe that we have to develop new instruments to measure the real value of nuclear, where you are talking about a 60-year lifetime project compared to conventional plans of 20 years or 25 years, and depict the picture clearly to investors. You know, banks had little to do with investment in nuclear. So at the end of the day, you have to project IRR concept to some banks and financiers just to let them more or less live with the concept at the beginning.
That's great. John-C, would you like to sort of comment on that in comparison perhaps to other energy mixes as well?
Yes, because so we alluded to this early on when we talked about the long wavelength of the nuclear program. And the reason the UAE embarked on its nuclear program was not about cents per kilowatt hour. It was a long-term vision for building, diversifying the economy, building technical capability within the economy, as well as the sustainability of supply, security of supply, and the sustainability argument. And how you value that and put all of that into the IR model is extremely difficult. It sure helps if you've got a reasonably large piggy bank, so that you can actually just crack on and make some of the brave decisions. But for those countries that haven't got a large piggy bank to fall back on, then the critical thing is reducing the construction risk. Funding is all about risk, right? It's the cost of capital. The cost of capital is all about risk. So anything that countries can do to, put their long-term vision into underpinning some of these projects by underpinning construction risk, and this is certainly what the UK is trying to do with some of the guarantee schemes that it's putting in, is going to bring that cost of capital down and in turn improve the IRR of these programs. But it requires national level leadership, national level vision, and thinking about the broader benefits to the economy of the program.
That's great. Indraj, you talked about construction risk, which links quite nicely into it, and construction risk is a big barrier quite often for private financing organisations. I guess my question is what needs to be done to try and overcome that perception of risk for private investors? Is it possible to overcome that risk?
I think it's difficult. I think if you look at technologies like wind, when they first started out, there was seen as a massive technology risk in that. Now, when you look at wind today, there's less risk. All people view the construction risk as less of an issue. And the problem with nuclear is that effectively, because the build period is so long, the technology is so complex, and there's varieties of models. I think it's a difficult one to build in without there being some adequate support from the government, and without there being some form of government guarantees, making sure the EPC is a fixed cost contract. Because I think, as Jonty, both Dr. Cullen said, that is a key issue in terms of looking at the IRR. And I think I also agree in terms of the earlier comments on the IRR that I don't think it's an adequate model for nuclear, because I think you do need to build in the sort of social benefits which come out of nuclear as well. As I said before, there is training individuals within your own country and building up that base and building up a separate economic base and effectively providing cheap power for the economy. And it's difficult to build that into that kind of model.
Okay, Andrew.
Yeah, I think there's two issues here. The first one is about understanding the construction risk, Adrian. I think it's about there are very simple methods to do that across the construction industry, and I think once they are understood, the communication of those to some of these private investors is where we need to get clever and simplify what is a really complex model. Dr. Toucan had an interesting slide that just showed those major elements that go into that assessment, and I think the key for me is understanding where the uncertainty sits and then being able to communicate that.
Yeah, and I think from my experience and observation as well is the commercial operating date and the security around achieving that in the model is very critical. A 12-month, 2-year slip can make a massive difference to the IR model because of the nature of nuclear power plant construction. I think just before I carry on to my next question, is there any questions the audience might like to offer up relating to sort of that investment question? Please. And do by all means get a bit more noisy. We do like a bit of active participation here.
Yeah, thank you. My name is Bernard Fauché. I'm a radioactive waste management in France. So my question is for Dr. Khaled Toucan. He mentioned that spent fuel will be shipped back to Russia. So I would believe that Russia will accept spent fuel only if they have sold let's say, new fuel to Jordan. So it means that you're losing some independence. It means that whatever fuel you have to buy, it has to be Russian for the next 60 years. Unless, and this is a very open question and a very exploratory one, here in Baraka, we are going to produce spent fuel as well. So are there any discussion in that region of the Middle East to have some kind of, I would say, a shared regional solution for spent fuel through a geological repository, for instance?
Yeah, excellent question.
Very good question.
Yeah, very good. And the IRR. Yes. Let me tell you what we are discussing with Russia. Now, part of the intergovernmental agreement is that we repatriate the spent fuel back to Russia. And typically, as you probably know, the convention with plants that Russia built previously in East Europe and some countries now which are considered part of Europe, like Hungary and so on, and that they will take the fuel back temporarily, but in reality, it's permanent. So this is good for a small country like Jordan, but I agree with you that I think it makes a lot of sense if UAE, Jordan, Egypt, Saudi Arabia now are thinking nuclear, that we should think of a regional nuclear repository, more or less like what you are discussing now within the European Union or maybe in France in Cadarache. But going back to your question about the supply of the nuclear fuel, you are right. Russia will take only the nuclear fuel that it supplies. And we were worried about this because I know, for example, there were the two top competitors were Areva and Russia. So there were strong points on each. In Areva, as a Western supplier, you have other companies who could make the fuel in US and so on, and you will not fall into a monopoly. Now, the good news we know is that now China will be able to manufacture the Russian fuel, which is now more or less manufactured only by TVEL. So the agreement that we signed with Rosatom is that we only limit ourselves for supply of Russian fuel for only 10 years. And then we have the option to tender and look for other suppliers. We know that China now is going to move in and hopefully break this monopoly. But you are totally right. This was a point of major concern to us, that you are becoming limited to one supplier. In the Hungarian nuclear power plants, they tried to work with Westinghouse. They did some test or installed some fuel from Westinghouse, but then they had some problems with it, so they have to turn back to the Russian supplier. So this turned out to be a monopoly. But you are right, but now we are, before we sign the contract, we'll make sure that we have more than one supplier who can manufacture this fuel.
Great, thank you. I've got about a minute or so left, and there's one other area that I'd like to explore a little bit further, which is the environment to allow nuclear projects to progress. And I think, Andy, you talked about the supply chain. Dr. Duhan, you talked about having the education of the people and all the politics around it. I just wondered if, I'd just like if you would, all of you would like to take a quick moment to sort of reflect on that a bit and sort of talk a bit about how you deal with that sort of supply chain, the whole environment to allow that project to work. Should we start off with that in this time?
Start with me. As I said when I was talking, I think that sustainable supply chain is incredibly important, and there is, in the current pressure, with the current cost pressures on the oil price and lots of things like that, there is a tendency to go for that low-cost option. And I think unless any capital project, but particularly a nuclear project, unless they can get that sustainability in the supply chain where they are thinking about these long-term issues, I don't think it will work. You've got to get that sustainability in, and I think there's a mix there, but it's not either or. Thank you.
Just quickly, Indraj?
I think having a sustainable life chain is key in terms of being able to project finance a project. I mean, you need that. That's what the bank's going to be looking for.
The challenge is scale. So there is a critical mass which will enable you to build a supply chain on a national level. That's clearly the intention. If you're running 4 reactors, how can you build a complete nuclear supply chain around that? So it's getting partnerships whereby you are sending people into the supply chain, you're encouraging the supply chain to base itself here and then operate from here. That's certainly the model for the UAE, but it's getting over that critical mass challenge.
Yes, I agree on the supply chain that it will also make a lot of sense that if a country procures a certain technology, hopefully other neighboring countries or within the region do have the same technology where you can share resources in securing a bigger portion of the supply chain. On the human side, I think also it makes a lot of sense to work also comprehensively to really develop as much know-how and actually in the presentation by Atkins, to really get your human resources involved from day number one as much as possible in construction and commissioning. And this is our experience in the research reactor there, because they will be they will play a pivotal role during operation. Otherwise, you'll really be so much dependent on the designer and supplier.
And Dr. Carlo, your lovely concept about sharing technologies in a region. In the UK, we've managed to get 3 technologies in our 3 consortia for our new wave of nuclear new build. So, woohoo UK for getting that one right.
just bear in mind how hard we worked to get that. We've run out of time now. I think probably just a few concluding remarks from me. I think, first of all, the program here in Abu Dhabi is outstanding, and it's achieved a lot in a very short period of time. One of the areas I would like to have spoken a lot about is nuclear regulation, but that's probably a whole topic in itself. And that's been accomplished all in the same time. The environment has been quite amazing. I think I'd like to pass on all our hopes go with you, Dr. Dukan, for your success in your program. And we'd like to see some more nuclear programs in the region. I think most countries now have, unless you are violently against nuclear, tend to see nuclear as being one of those technologies that is a very viable solution within the technology mix, providing good baseload type production. I think we've spoken a little bit about the financing side of this and the recognition that financing is critical to this, and actually project delivery and reliable project delivery is critical to that. And finally, when you start these projects, there really is a need to engage a bigger environment, including the expertise and supply chain to be sustainable projects. I hope that all of you have gained something from the discussion up here. I'd like to pass my thanks on to all the panelists here who I believe have been fantastic and made a terrific contribution to the debate. And I thank you all for listening. Thank you.